Okay, so we have started to look at how to sketch linear relationships or how to draw linear relationships when you're given the equation. And in our last lesson, we learned how to sketch a linear relationship from using a table of values, which worked great. However, sometimes using a table of values can take a long time. It's a little bit tedious because you've got to do a lot of calculations and plot a lot of points. So it's always nice if we can have a shortcut that can help us graph a little bit quicker. So the nice thing about linear relationships is that because of the characteristics we know about linear relationships, we can use those characteristics to help us sketch lines a little bit quicker. So I'm going to go back to the practical example that we looked at before, and that was the gym membership cost. So we saw that the cost of this gym membership was equal to 10 times the number of months plus 50. And what we can do to make this process a little bit faster is we can pick off the rate of change in the initial value and use that rate of change in initial value to help us sketch it in a really efficient, time-sensitive way. So again, when we looked at this equation, we decided that the initial value for this relationship was 50, so $50 to join the gym. And then from there, the rate of change was $10 per month. So the 10M, which the rate of change is going to be 10. So when we write rates of change, we know that rates of change are equal to rise over run. So when I have the number 10, it's just the number 10. So I know that the rise is going to be 10. And if I want to write the number 10 as a fraction, I know that 10 is equal to 10 divided by 1, or 10 over 1. So that basically means that if I'm going to rise 10, then I'm going to run 1 every time I rise 10, because 10 divided by 1 is 10, and it doesn't change its value in any way. Okay, so I picked off the initial value of 50. I see that the rate of change is 10 over 1. And now what I can do is I can go back to my grid. So again, this is the same graph that we had in the last lesson, or the same grid set up the same way. And I'm going to start off always by plotting my initial values. So I put my little blue dot there at 0, 50. And what I'm going to do is I'm going to put my pencil on the 0, 50, and then I'm going to use my rate of change to help me generate more points. So I know my rate of change is 10, or 10 over 1, and I know that rate of change is equal to rise over run. So starting at the 50, I'm going to rise up 10. So again, I'm using the scale that I created to go up 10. And then I'm going to run 1. So again, on my scale, 2 blocks is 1. So I'm going to rise 10, run 1. And that's where my next point is going to be, because we know that 160 is a point after 1 month. And then from that point, I can do the same thing. I can rise 10 and I can run 1. So there's my second point. 2 months cost me $70. And then from there, I can rise 10, run 1. And there's my third point, 380. And then rise 10, run 1, rise 10, run 1. And you'll notice that when you do this, when you use your scale combined with the rate of change, again, your points should all line up to be a linear relationship. And you can just sketch your line through those points to come up with the linear representation. Okay? So instead of doing a table of values, you can pick off the rate of change, you can pick off the initial value, plot your initial value, start with your pencil there, and then use your rise over run, rise over run, rise over run to get the additional points on the graph. Just keeping in mind that you need to be very careful about the scale that you're using and making sure that that's corresponding to your rise and your run that you've identified as being your rate of change. Okay, so that can save a little bit of time instead of having to do the whole table of values. And the same idea we can use when we're doing our more mathy examples, like the second one that we did, which was graphing the line y equals negative 2x plus 4. So I'm just going to zoom in on this a little bit. So when we have the line y equals negative 2x plus 4, the first thing I'm going to do is I'm going to pick off what is my y-intercept, and I'm going to pick off what my slope is. So I know that the y-intercept is the number tagged on to the end here. It doesn't have a variable attached to it. It's a constant value. So I know the y-intercept is going to be 4. And I know that the rate of change, or the slope, m, is always attached to my independent variable. So in this case, my slope is going to be -2. So my y-intercept is 4, and my slope is -2. And again, I know that my slope, or my rate of change, is rise over run, which is helpful to have it in fraction form. So the number -2 is -2 over 1 when I write it as a fraction, because -2 divided by 1 is -2. So whenever I'm using this strategy, I always write my slope as a fraction. So I'm going to go over to my Cartesian plane, and I'm going to start by plotting my y-intercept, just like I did above. So I'm going to go up to the point 0, 4. There's my y-intercept. It hits the y-axis at 4, and I plot my point there. So there's my blue point right there. I'm going to put my pencil on that blue point, and from there I'm going to use my slope to help me find new points. So my slope says that I'm going to rise -2 and run 1. So, sorry, excuse me. A rise of -2 means that I'm actually falling 2. So I'm going to go down 2, run 1, down 2, run 1, down 2, run 1, down 2, run 1. And again, because I started at my y-intercept and I've used that constant rate of change to generate some new points, I can draw my line through those points and I get a good picture of what that line looks like. Okay? So this strategy is great. It can be a little bit faster than having to use a table of values to calculate all the different points and plot them on. I just plot my y-intercept first, and then use my rise over run of my slope to come up with the rest of the points, and then again, draw my line through the points. Okay, so I want to take you through just a few more examples of how to do it this way, because there's sometimes some little tricks that come up. So first of all, this was a negative slope, so that you can see that it is going down to the right, which makes us think of a negative rate of change. I'm going to show you one with a positive rate of change up here. So this time I have y equals positive 2 over 3x minus, or plus 1. And if you, again, we're going to pick off the key pieces of information here. So I want to know what my y-intercept is, and I want to know what my slope is. So my y-intercept is the constant value, the one that doesn't have a variable attached to it. In this case, it's going to be the 1. So I know that my y-intercept is going to be 1. And my m, or my slope, is the number attached to the independent variables. So the number attached to it is 2 over 3. So I've got my 2 over 3 as my slope. It's a positive slope, so when I graph this, I'm going to expect it to go up to the right. And the nice thing here is actually it's already written in a fraction. So I know that the rise is going to be 2 every time I have a run of 3. Okay, so I'm going to start by plotting my y-intercept at x, or at y equals 1. So there's my 1. I'm going to put my pencil on there, and then from there I'm going to rise up 2, and I'm going to run across 3, and I'm going to plot a new point there. And then from this point, I'm going to rise up 2, and I'm going to run over 3, and I'm going to plot a new point there. So I can see that these points line up, and I've got the line going in this direction. Okay. I also want to point out to you that you can also go in the other direction. And that's because if I have the fraction 2 over 3, that is the same as the fraction -2 over -3. These are equivalent fractions, because if I divide a negative divided by a negative, I'm going to get a positive back. So 2 over 3 is the same as -2 over -3. So if I think about it this way, again, I'm going to start at my 1 here. This means that I would go down 2 and back 3. So from my 1, I can go down 2, back 3, get a point, go down 2, back 3, get another point. And you can see that all 5 of these points now clearly line up to be my line. And when I put my line through it, I get the sketch, or visual representation, the graph of y equals 2 over 3x plus 1. Okay, so again, we picked up the y-intercept, we used the slope 2 over 3 to get the new points, and then we can draw our line through those graphs, or through those points to get our graph. Okay, I do want to also point out what happens if I have a negative fraction. Okay, so in this case, we're going to graph the line y equals negative 2 over 3x plus 1. So once again, I pick off my y-intercept, which is 1. And in this case, my slope is going to be negative 2 over 3. Now remember, when we have a negative fraction, there's 3 ways we can write it. So we can write it with the negative out front of the fraction, like it's written in the equation. We can stick the negative up top with the numerator, so that would be equivalent to negative 2 over positive 3, because that's going to be a negative number. But I could also put my negative down with my denominator, so that would be equivalent to 2 over negative 3. So these fractions all mean the same thing, okay? And it doesn't really matter which way we write it, as long as we only have one negative. So either negative on the top or negative on the bottom. Negative with my rise or negative with my run. So I'll show you kind of how this works when we transfer it onto the graph. So again, I'm going to start with the y-intercept. Always start by plotting your y-intercept at y equals 1. So there's my blue point. I'm going to put my pencil here, and I'm going to go with this one first, okay? My negative, where I put my negative with my numerator, so negative 2 over 3. So I start at y equals 1, and then I'm going to go down 2, and I'm going to go over to the right 3. There's my new point. I'm going to go down 2, over to the right 3. There's my new point. If I had chosen to do it this way instead, where I have the negative on the bottom of the denominator, that means that my numerator is positive and my denominator is negative. So that means if I start at 1, I'm going to go up 2, and I'm going to go back 3. And then I'm going to go up 2, and I'm going to go back 3. So again, when I look at all of those points, they've all lined up because I've graphed them all correctly. I've just gone in different directions depending on where I chose to put the negative in my slope. Okay, and again, I take my line, I stretch it all the way across that graph, and I make sure I label it at the end there. And one last example I just wanted to go over. This one's a little bit of a trickier one. I want you to graph the line y equals 1, okay? So again, when we're graphing a line, I want to pick off what my initial value is and what my slope is. So here, my initial value, or my y-intercept, is always the constant term. And in this case, the constant term is 1. There's no variable attached to it. It's just the number 1. When I look for my rate of change, or my slope, I look to the x, the number that's attached to my x, the number in front of my x. And in this case, there is no x. So because there's no x stated here, I can say, well, that must mean that there's a 0 in front of the x to make it go away. So in this case, I would say that the slope is equal to 0 because there is no x term there, which means the 0 must have helped it to disappear. When I write 0 as a fraction, I write 0 as 0 over 1. So my rise over my run is going to be a 0 rise for a run of 1. So if I take this information and I plot it on my graph, I have my b is equal to 1. So I'm going to put my point out, my y-intercept of 1. And then from there, I'm going to rise 0, run 1. That takes me to here. I'm going to rise 0, run 1. Takes me to here. Rise 0, run 1 from here as well. Okay, so you can see that a rise of 0 just means I'm going to basically flatline it across in this direction. I could also do 0 over negative 1, and I still get 0. So I could rise 0, go back 1, rise 0, go back 1, rise 0, go back 1 to get points in this direction as well. And again, when I draw my line through those, line them all up, I get this flat line here. Okay, so when you have something in the form y equals just a plain number, that plain number is going to be your y-intercept, and you know that your slope has to be 0 in order for the x component of that line to disappear, your independent variable to go away. One thing I want to just note here, for the line y equals 1, you'll notice that every single y value on that line is equal to 1. Okay, so there's a little hint for you. If the line y equals 1 has every single y value equal to 1, what do you think the line x equals 1 would look like? And I'll leave you with that thought.